Hello, everybody. Welcome to our session on Inga alley cropping and how agroforestry can prevent deforestation. So we've got a lot to get through, and I am joined from Ecuador, from the Ecuadorian Amazon, by José Ramírez, Stephen Mansaray in Sierra Leone, Martin Lukac in Reading University. And so we will be dashing through in an hour some presentations. So with no further ado, let's share my screen and give you an introduction to Rainforest Saver. So this is about regenerating the soil, sequestering carbon and saving the forests using the technique Inga alley cropping. So I've spent the last 20 years working in the Amazon, and I'm a solutionist, and agroforestry is one of those solutions. So first of all, hats off to Mike Hands and Terry Pennington, who have spent their life's work looking at the genus Inga. And Rainforest Saver have been primarily working in Ecuador and in Cameroon. So our partners in Cameroon actually found the seed that it's not growing natively there, but it's being used around the world in coffee and cacao plantations. They heard about agroforestry and they started the projects there in Cameroon and have been having amazing success. It was also from those seeds that got taken to Sierra Leone that Rory's Well, who you'll be hearing from Stephen later, started the alley cropping over there as well, using the Inga seed. So this is where we're based, on the border of Colombia and Ecuador in the Amazon. And my real reason to do this is how can we prevent deforestation? So, agroforestry is definitely one way we can help local people to regenerate their soil. So the problem that we have in the tropics around the world is slash and burn. And with heavy rain, it just washes the waters into the rivers. The soil becomes infertile, people use agrochemicals, and then they abandon the land and slash and burn more forest. And that is how agriculture is working. So one of the solutions is agroforestry using Inga edulis in alleys in this chop it and drop it method to basically grow soil between the alleys. So this is the delicious seed, the ice cream bean tree. We actually don't grow it for the seed, for the fruit. We're growing it for all the other benefits, which you will hear of during this presentation. So that's what we're looking for, an alley. And that's what it looks like after it's been pollarded. And we are growing a vast number of different crops in between the alleys, up the trees as vines. They are then taking the mulch into their greenhouses and using that for compost as well. And not just food crops, we've also been growing hardwood trees between the alleys, including balsa, which at the moment, such a demand for wind turbines, and they are actually cutting down the forest for balsa, which are used in wind turbine blades. So we're also growing those between the alleys as well. But Inga edulis, or Inga, has been known for a long time with coffee and cacao plantations around the world. And we had like a bit of a big surprise. And I know this is a big call. Could Inga help save chocolate? Well, what's happening is that cacao was taken from the forest. It is now under threat by fungal pod rot. And so, the people will throw fungicides at it until they can no longer afford the fungicides. Then they abandon their cacao plantation and cut down more forest and grow more cacao. Jose accidentally found out that our alleys that were growing next to cacao, the cacao was resistant to pod rot, which is how we then got involved with Reading University to find out if some studies could be done to find out what was going on here. So we've just had our first master's student, and looks like some PhD students coming down as well, because obviously this is big news. So what we're really doing is education. When I started the project in the Amazon in 2016, we trained 400 farmers and students, put a nursery together of 4,000 seedlings. But since then have learned it's actually better to just directly plant straight where you're going to grow rather than transferring seedlings. And you wouldn't see this in England, students waving around machetes, but that is part of the education of what we're doing, is how to pollard. Also the science and measurement, the weighing the leaf matter to calculate how much nitrogen we're fixing, looking at how much carbon is being sequestered through this system, and setting up all different kinds of comparison sites. So working with the farmers as well on kind of citizen science, so they understand what we're doing is a big part of this project. And when we do the comparison sites inside and outside of the alleys, the farmers will say, well, what's the point? Because nothing grows outside the alleys. It's so hard and compacted. But that's kind of part of it you see with your own eyes, and their neighbors see as well the difference of using this kind of system. And we can clearly see the vast increase in yield of what's happening. And our latest results on our soil samples showing an increase in phosphorus is also huge news. And obviously there needs to be a lot more studies done, but this is what we're showing to start with. So there's huge amounts of benefits of Inga. I won't go into them now, as the other guys will do, but hopefully we'll have some time at the end. I want to just go through and just show you all the other advantages. People talk about, carbon offsetting. Well, there's a lot more advantages. A lot more of the SDGs are ticked through these kinds of projects. We've got carbon partners that are realizing that these kind of projects are so much more important than just tree planting. But really now, let's just hear from the words of the farmers themselves in the Amazon.
Bueno, aquí veo que cuando en la siembra de los guavos que se ha hecho, pues el suelo se ha puesto más suave, la tierra más blandita, un poco húmedo, y como que se le mira que tiene más abono. En cambio afuera la tierra es más dura, más como que está compactada, entonces esa es la diferencia.
Y aquí se le mira el cambio de suelo, porque esa parte era tierra amarilla, ahora se le ve el cambio total. Y también los cultivos, como el cacao, papa que he sembrado, frijol que hemos sembrado, que ya hemos cosechado, hay un cambio bastante significativo.
Aquí estamos indicando las plantas de café.
Y el carguillo que está ahí.
Sí, y lo bonitas que se ve, el carguillo debajo del Inga. O sea, no tenemos, tenemos sombra, tenemos una sombra variada, y el café tolera mucho este sistema. Se ve muy cargado esto, muy bonito. Ahorita vamos a mirar una mata aquí de café debajo del Inga, y también vamos a mirar fuera del Inga para ir sacando la diferencia. Ya, entonces, como podemos observar, la planta fuera del Inga, en primer lugar pequeña, no hay fruto, no hay casi nada de fruto, y el coloración amarilla. Entonces ahí vemos la diferencia que nos muestra que el Inga es muy útil, muy importante para el sistema de cultivo.
Sí, aquí en el momento que comencé a sembrar la guava me ha dado muy buen resultado, porque he hecho ya 3 cosechas de maíz. Y el maíz ha sido una excelencia, porque antes de sembrar la guava, este terreno era, mejor dicho, duro, que no tenía abono, pero con la guava está más suave la tierra, como usted lo ve.
Aquí estamos mirando el resultado de la hoja de guava que se descompuso, y el suelo que era apretado, duro, aquí se lo ve un poco más frágil ya. Entonces con esto las plantas tienen un desarrollo más, porque ya no hay la tierra apretada que era antes. Entonces con el siembra de guava, pues para mí es un éxito trabajar un agricultor con un proyecto de guava así.
El proyecto es magnífico. Yo tengo una experiencia que lo he vivido, que aquí lo muestro. Mire, la edad del cacao con la edad de la plántula de la guava que decimos. Es ella, esta está anteayer nomás trasplantada. Una diferencia que aquí está, que esto ya va para 2 años de cacao. Sigamos. estas, que son las que están sin las guavas. Miren. Hoy les llevo a mostrar con las guavas. Esta es la diferencia de la misma que le mostré el mismo día de siembra y la misma calidad de cacao dentro de las guavas. Es ella. Miren la diferencia, cómo las tengo. La diferencia que hay de lo que es de las plantas dentro del callejón, el cacao supera el 1,5 metros de altura y el fuera del callejón unos 50 centímetros de altura. Dentro del callejón de 1,5 años comenzaron a echar flores y fuera del callejón hojas. ¿Qué pasó, mamita? ¿Qué te caigo? ¿Dónde? ¿Qué pico?
So we know that 1 million animal and plant species are now threatened with extinction, many within decades, more than ever before in human history. So it is vital that we protect these key biodiversity areas. So I'd like to invite José Ramírez, who is in the Amazon, and he's going to come and join us now. So José, are you there? You turn, José, ¿puedes aprender? No, no puedo verte. Ponga
Jose, if you could turn on your camera.
tu cámara.
Hello, everybody. I'm part of this project and I have been for more than 4 years, and I've been working here in Zumbidos with the different farmers in the region. And we've been doing field monitoring work, and our main goal within the project is to, according to the foundation, is to avoid the cutting of natural forests and recovery of soil. This very important project is located in north of Ecuador, in the border with Colombia, in the Sucumbíos province, and here we've got the map. So who do we work with? We are working on the 7 cantons in the province with 6 different schools and more or less 150 students who join us, with also farmers and the different communities, as well as individual farmers. Today we have 67 beneficiaries. After 4 years, we've noticed that the soil where we did not grow anything is compressed with monotonous planting, and it has been practically abandoned, and we've grown, cropped our alleys, and the soil is more spongy, it retains more water, there's more nutrients, and it's more adequate for planting any kind that we can here at the Amazon.
So you can see the soil before. It was very hard, it was compacted. The color is more yellowy. Now, over time, when we've sowed our alleys, it's spongier, it has more nutrients, and microorganisms, microorganic life above all, returns once more. compared to virgin forest. So we sow also on slopes, sloped ground. We use our shape system to avoid erosion. There's a lot of rain in the Amazon. So if we make sure that we sow in the right pattern, on the right contours, then we can avoid erosion and make full use of the system. The sowing density that we use here, we've seen to be very effective. A meter between plants and 4 meters between alleys. We've always done this working with students, with farmers, working at the start together. This is a way for people to learn and for reproduction in other farms. We do pruning from 1.5 years. This is when the trees are around 5 meters in height. This means we can get better foliage. Also, we do pruning, working with students, with farmers. We use the lunar calendar. We've been able to have more pruning in this way. The moon does affect our plants, and we make the most of that opportunity. Then we wait up to 4 weeks for the foliage to dry, and then we keep sowing our products. After pruning a few times, we see a notable improvement in the soil, and our crops start to grow really well. Also, the firewood that we always get from our pruning of the Inga trees can be used. We put it to one side for it to dry, and then we can make charcoal. As we can see here, it's an open fire here. That's what we always do. We use this biocharcoal, this organic charcoal. When we are growing our cowpeas. If we use this organic charcoal, then it can grow well. Also, we don't get pest problems or so many problems with predators. Also, with our cocoa, we've been combining Inga with cocoa, and we've seen better production. So away from the alleys, you can see here a comparison. So sown at the same time, these cocoa plants are in a terrible state. And in the Inga alleys, we can see that it's growing well and the product is good. Also, we've been increasing our Inga use alongside rice. It's not the most common crop in the area, but if you use our system involving Inga, we've seen good crops of rice Also, bananas. That's gone very well. We've even had 3 harvests of bananas. Cassava. It's used very widely for food here in the Amazon. We have achieved better flavor, up to 35 pounds per bush. This is in combination with Inga. Also, we've been growing fruit. They've been very big, very sweet, and the flavor's been very good. We've been sowing in our plots with the Inga, all of the crops that grow well here in the Amazon. So these products are really in demand at markets and fairs. We always take them along to sell, and the farmers can help with this. We have then economic beneficiaries from this. This project has helped in all areas. It's helped us to produce large organic produce, which is in great demand with the public when we take it to market. Also, we've noticed that alley cropping has really helped with weed control. This saves us work. Often, it means we don't have to use herbicides and chemical products. This system is really helping us in various ways. So we've visited other educational institutions and universities, secondary schools. We've done field work together so people can learn, and then it's possible to replicate what we've done with other students. We've seen that Inga does very well with our crops. It improves shade. It improves our production with this system, especially for orchards and fruit trees. So Inga, together with maize and bananas, has been really positive. Due to the high levels of nitrogen that is then left in the soil. Also, we've been able to grow tomatoes and other forms of horticulture. You couldn't do that normally, but in our alleys, we've had great success producing really good tomatoes. And what we've seen in our demonstration plots, working with farmers, is this. Within the Inga alleys, we've got really green, strong plants, and outside these alleys, we can see that the plants are more yellow and the amount of product is much lower. So the farmers learn watching and working together. Thank you very much. Thanks. In the name of the poor children in the Amazon, we are very grateful. Thanks to our listeners. Hopefully, we can continue to have this mutual support for future projects.
Thank you so much, Jose, for sharing that with us directly from the Amazon. And now going from the Amazon over to Sierra Leone, we're going to invite in Stephen, and I'm just going to share your slide as well, Stephen. Okay, welcome, Stephen. Here we go. I've just got your slideshow up for you, so welcome.
Yeah, thank you very much, Nicola. Hello, everyone, all listeners to this novel platform of Oxford Real Farming Conference. My name is Stephen Mansaray, the country director part Sierra Leone, and then a man in charge of the Inga farming in this country. I was born in Mansaray village, Barry Chiefdom, Kujahan district in South Sierra Leone. I am presenting on behalf of Ramírez Charity UK and PAD SL Sierra Leone on a topic, growing Inga to feed the people, feed the soil, and protect the forest. This is our major objective. Years back, this is our major objective. In the slide you see is where the Inga demonstration farm is established in Sierra Leone. That is in Barry Chiefdom, Kujahan district in southern Sierra Leone, where we have established this Inga foundation. To the next slide. Years back, this Inga was brought into Sierra Leone based on certain circumstances which we encounter with our community people. Ramírez and PAD Sierra Leone 6 years ago empower community with inland valley swamp for men, and we empower the women also on the upland farming to plant vegetable. We also empower the community with good drinking water and many other livelihood projects. But our major objective, which I said, was to protect the soil and the forest and to feed the people. In this regard, we also encourage the community to learn a very simple and a basic experiment from the Inga Alley farming system, which we refer to as ecological friendly farming system. We set a basic scientific experiment on 3 different plots of land. First land, which we refer to as 2 years prune Inga Alley plot. Another land, which we refer to as Inga orchard with rock phosphate. Another land is what we refer to as a traditional farming land. This traditional farming land is just like this slashing and burning method of farming, which we refer to as traditional farming land in this presentation. After setting up this experiment, we do thorough investigations and observations. From the 30th of June 2021 on to the 20th of August 2021, we observed that the maize grew very well in the 24-month Inga Alley pruning plot as compared to the newly planted Inga orchard with rock phosphate and the traditional farmland. The ratios of maize yield in the 24-month Inga Alley prune encourage the women to embark more on planting Inga in the Alley farming system, which is our objective. Because looking at the yield, we are able to harvest 10 bags of maize of 25 kg each from the old plot, which we refer to as 24-month Inga Alley plot, and 5 bags in the orchard, but where we have a rock phosphate. And these 5 bags only proved because there was a rock phosphate on that particular land. So we only harvested 1 bag on the land that we refer to as a traditional farming land, because the Inga Alley farming system is the best way of farming in this particular part of the country, wherein shifting cultivations have destroyed almost all the vegetations of our forest. So therefore, we encourage the women, and the women are very happy to embark on this particular farming system. Looking at all the community that we have empowered, women and children are very happy because they now have the ideas. They have now buy the ideas that they will follow us to do Inga alley cropping system, or which we refer to as the agroforestry system, so that they will allow the forest to grow. In this regard, looking at the women, in every villages, they have seed rice, they have groundnut or all vegetable seed, as well as the men. Like I set a simple examples in one community, wherein we empower them with tools, food for work, cash for work. At the end of the day, within this year, they now have seed for themselves, for the subsequent farming. They also have food for their family, and they have surplus to sell so that they can build up their own family for future. Looking at this principle, a lot of people are coming to show the listeners about all what we have done in Sierra Leone in order to help fight this climate change. Therefore, the videos will come in and everybody will listen so that you can learn from this point. I thank you for listening.
Thank you so much, Stephen. Like you say, there's a great video now that we're going to share of your work there in Sierra Leone. So let's have a look at the video.
Agroforestry always works with communities. The upland farms traditionally are individual farms, but the women's upland farm is a community farm.
The women embark on this upland farming. They were planting beans and groundnut and so on. They will also plant a pigeon pea, broad beans, cowpea, maize. Now the children, their body begin to change because they now have good drinking water and nutrition food.
Couple na me lo hin gbe imagesi go be fo anu ma ga happy olola e anu mu le every save keto wa ma gbo ba be rest busy ake bo kokko ga ga mana.
I realised the impact that a little bit of income of their own was having on the lives of the women in the villages. They were able to set up microcredit, hardship schemes, little businesses. Unfortunately, these benefits only lasted for about 2 years because, in common with all the other upland farming, once an area is cleared by slash and burn and cultivated, it rapidly loses its fertility.
We are fighting for the future because if we continue this slashing and burning, at the end, there will be no forest.
We spent a lot of time researching different ways of doing this and came up with Inga alley cropping, which was a technique developed by Mike Hands in Honduras.
Inga farming is something very important, not only for me, but for everybody. Inga is coming to help to recondition the soil for the farmers, to restore nitrogen into the soil, phosphorus and potassium. But more especially, it adds the biomass on the soil, which helps to improve the nutrient of the soil.
Inga is a very rapidly growing leguminous tree. It also has a very strong leaf which forms what's called a recalcitrant mulch, so it's slow to rot down. As it rots down, it protects the soil, it increases the biomass, and it's also a very good medium for mycelial growth.
From the day Inga is being nurtured to the time we are expecting the fruit, it's approximately 2 years. It produces fruit almost year round. We normally establish nursery to provide seedlings for planting. They do not have dormant stage. Germination is instant, and in the space of 2 weeks, seedlings are 10 to 15 centimeters tall.
From the day you unshell the seeds, put it into the polythene, it takes 3 months, you do transplanting. If there is nothing done here, at the end of the day, before the rainy season finishes, you will see all this topsoil will be washed away and taken down the hill. Inga is coming to reduce or to even eliminate erosion by planting the Inga by the side of the hill, not straight down. It holds the soil together, and the leaf also will serve as a blanket, so the soil will be highly protected against erosion.
What happens in Inga alley cropping is the trees are planted in rows about 1/2 metre apart. The gap between the rows is about 4 metres, so you effectively have hedges. They grow up for between 2 and 3 years until the canopy closes overhead, shading the soil underneath. During all that time, the leaves have been falling and building up a blanket over the soil, which also suppresses weeds. So at the point that the weeds are suppressed, then the Inga is cut to approximately 5 foot, so it's pollarded. The wood is taken for firewood, and the leaves are laid on the ground, and then the crop is planted into that mulch. As it grows up, the Inga grows with it, shading and nurturing it. The crop grows, and the one that we've tried so far has been maize. It's harvested. The experiment that we did last year showed we had 10 times the crop of maize in the Inga alley than we did in the nearby normal farming plot, and the Inga is then left to recover. And we've seen when we've travelled around that within those few months it is back to closing the canopy overhead. It's a very rapid recovery. So then the cycle repeats again, and the depth of the mulch increases each year. So unlike slash and burn, the land is becoming more fertile for the longer the Inga is there. I was very impressed and very humbled by what the women in their women's farms were telling me they had achieved with a very small amount of money from harvesting vegetables. And that was why I felt so strongly that we should put Inga into their farms so that they didn't have to keep moving them, and to increase their yields. So that is the thrust of putting the Inga in the women's farms. We are also planting orchards in the women's farms and giving them a potential income stream.
The orchard is a mother tree. Here, we don't prune any tree. We allow them to grow because we get the seed from them. In this orchard, we are going to plant coffee, cocoa, plum in between them. so that the space or the gap will be filled up with other economic tree. But at the middle, we plant like a cash crop or any other mahogany trees, which we can use in future for plank and so. So we expect within 3 to 4 years, this cocoa will be producing even more than the one that they met in the normal plantations.
As those orchards produce seeds, which should be within 2 or 3 years of planting, they will be able to then sell those seeds and people can develop individual Inga farms. We've also been very lucky to have been given funding by Lush for an Inga training centre.
This centre is dedicated to the lasting memory of Tony Ivan and Chief Kalfala Mansaray.
Each village will not only have the Inga planted, they will know how to look after it, how to raise their own seed from the orchards and plant their own alleys. The potential of this technique is absolutely enormous. With support, the Training Centre and Inga programme could spearhead collaborative research and development, taking the benefits of Inga throughout Africa.
So definitely, this was use, yeah.
So that was great seeing how, you know, the impacts of the social side of the work of agroforestry and Inga alley cropping, as well as the environmental benefits, and how important it is for all of us that are working with these techniques to come together. You know, us in the Amazon and in Africa, and there's another group that are in Belize, Yache. So that's what we're really here to inspire other people that live in the tropics to be able to expand this network out. So we're just going to go over now to Martin Lukac, who we are working with at Reading University. And Martin, to see how can we take this to the next level scientifically to bring in the studies that we really need. Over to you, Martin.
Thank you, Nicola. I hope I'll be able to at least give an indication of how can we take this to the next level. My role in this collaboration, and indeed today, is to come at Inga Agroforestry from a different angle. So we have heard from the practitioners on the ground, from the farmers and the growers themselves. What I can do as a researcher is to try and show you perhaps how we can put together some scientific evidence to show how do these systems work, why do they work, and how can we make them even better, perhaps. So that's my goal today. I don't have any data in my presentation. This is just as a concept, how can we possibly go about it? So just to give you a brief overview of what I'll be talking about, I'll describe how do these systems work, what's inside, what are the components, how do we put them together, how do we put an Inga agroforestry system together. Indications of that you have already seen in the presentations and the videos from Stephen and José. One of the most important bits of these fairly complex systems are the interactions between different components. That's what we are trying to work with. And finally, the last bit is what is the learning? How can we actually make sure that people use the science we generate? How can we make this useful for anybody? So that's the outline of what I'll try and do today. Slide 1, agroforestry basics. This is the case for Inga agroforestry, but this is the basic slide for just about any agroforestry system, or indeed for just about any agricultural system in the world. So what I have done on this slide, I've just stripped down photosynthesis to the bare basics. This is the simplest way I can think of showing this. What we have on here is 4 essential inputs, so carbon dioxide and energy from the top, and water and nutrients from the bottom, which the plants, photosynthesizing plants, use this for in a process called photosynthesis to generate biomass, which for people such as you and I means food, or alternatively, if we keep some livestock, that means feed for the livestock. So this is essentially the basic formula of life, and we cannot escape from this. So if I run a farm, this is the basic mechanism behind anything I do. I cannot run away from this equation. That's impossible, at least not on this planet that I know of. So if I take my basic scheme for photosynthesis and I put an agroforestry system, such as an Inga system, into this, this is what I get. I have a largish plant, the Inga tree, which is taller than the rest of the vegetation. And then underneath the canopy, as we have seen in the videos, there is my crop, which is protected and shaded by the Inga tree. But what we have to understand is that the Ingas, they compete for energy, as in the sunlight from the top, and they compete for water and the nutrients which come from the soil with my crop. So the challenge number one is to make sure that the product or the produce that I want to get from my system is optimized, or the resources are allocated well between the crops and the trees. Okay, so in a simple arable farm, I don't have the trees and I can focus just on the crop. In the case of agroforestry system, this is already a little more complicated because I have two types of plants in the same field at the same time. So one of the simplest ways to think about this and to try and understand what's going on is to split it into two groups or into two parts. One is the above ground bit and the other one is the below ground bit. So think of it as the bits that we can see. These are the parts of the plants which we can touch and manipulate. That's the above ground bit. And then we have the bit that happens in the soil, the below ground part of the system. This is where the plants acquire water and nutrients, and this is where they compete via their root systems. Okay, so we have two basic components which we can work with. One is the above ground bit, which we can see. The other one is hidden in the soil. A very important element in this consideration is that the above ground bit and the below ground bit must be in balance. So I cannot just keep on increasing, for example, the energy uptake in the system without increasing the water and the nutrients to balance it out. If I try and do that, my production system will run out of kilter and stop producing. So that is perhaps that's one of the things that we saw in Stephen's video, was the need to move the farms continuously because the soil becomes exhausted. So that's an example of the imbalance. If I have less nutrients in the soil, I can have all the energy in the world, but it's not going to produce food. So looking just at the Inga systems, what we have, I have four basic components in here, which I can try and understand how does the system work. So the first two, the soil and the crops, such as the maize or the sweet corn crop that the farmers had in Sierra Leone, these are the normal components of any arable field. I need a soil and I need some crop to grow in the soil. What we add, and the bits that are highlighted in bold here, are the trees in an Inga system. And then, because the trees stay in place and they create a three-dimensional structure, the canopy, what I also get is some wider biodiversity. There are more things, more life forms, more creatures moving in because I have the trees in place. So I already bring in more wildlife into the system. And there is the fifth component, which I didn't put on the slide here, not to confuse it too much, but which I think is crucially important. And the fifth component are the farmers themselves. Okay, so we need to make sure that the farmers who actually create and manage these systems understand how does it work altogether. And one thing or not, they are an integral part of agroforestry system. This is very important point. So if I look at the above ground bit, the interactions, which I mentioned at the beginning, so the trees influence the crop And I think the crops influence the trees because they grow in the same plot at the same time. There is no way they can get out of each other's way. So looking at the above ground part of the system, what we can see or what we need to understand is the competition for light. This is perhaps less important in the tropical systems where the light intensity is fairly high. The competition for light becomes more and more relevant as we move away from the equator in agroforestry systems. So the trees shade the crop. If the light is plentiful, this is beneficial. If the light is not sufficient, this may be a problem. The second bit, microclimate creation, as the Inga trees in our case expand and close the canopy, they will create a different kind of climate for the crop. Some of the effects and the increase in the yield of maize, for example, that we saw in the video may be due to this. So the trees create a special kind of climate for the crop. And if it's done properly and we understand how does it work, we can increase crop productivity. In some locations where water may be limiting, water interception by the tree canopy may be a relevant interaction, in that some of the water that falls from the sky doesn't really reach the soil. It's just captured by the canopy and then evaporated back into the atmosphere. So this may be an important factor. Habitat creation, this is a nod to the biodiversity that is moving in that I mentioned before. So the trees are in place, they create a structure which was not there before. They create a food source which didn't exist before they were planting. So there are creatures that are moving which utilize these elements, these parts of the system. And finally, there is nutrient recycling. This is something which was beautifully demonstrated in Stephen's video by the leaves falling to the ground and creating a mulch and then decomposing slowly. So what the trees are good at, and what I'll show you in the next slide, is they are good at taking nutrients from deeper soil because they have longer and deeper roots. They put them into the leaves and then the leaves fall down on the ground, recycling the nutrients and essentially fertilizing the crop in this way. So this works really well. We understand this fairly well. So if I move below ground, okay, so from the above ground bit and I come into the soil, the critical interactions I need to pay attention to are the competition for water. This is in places where it doesn't rain sufficiently. The trees will compete and in some instances outcompete the crop for water because they are far better at exploring the soil for water. Apologies. The second bit, soil formation. This was shown in José's video fairly beautifully. So the soil tends to be hard and tends to harden up without the trees or without the root growth in the soil. The Inga trees can create soil aggregates and can speed up soil formation just because they work their roots through the soil. So carbon content increase and soil aggregation are very important to soil formation, and we know that the Ingas are fairly good at this. And finally, the last one, microbial symbionts and soil pathogens. This is something I am very interested in personally. This will be the mycorrhizas that grow on tree roots. They would not exist in this field without the trees. So as soon as you plant the Inga trees or many other kinds of trees, you get fungi which grow on tree roots. And these fungi are perhaps even better at soil formation and exploration than the roots themselves. They have an interest in protecting the tree from pathogens, for example. So this, I think, is something we may focus our attention as we go forward, because I think this is a very important and interesting element of these systems. So that's how they come together, that's how they work, that's the interactions we are interested in. And what have we learned so far in our collaboration with Nicola and all the others, is that the observations that we have, they need to be repeatable. So if a farmer sees, I don't know, there was a hint that the Inga trees or the presence of Ingas stops the pod rot in cocoa. Does this work in every farm? Does this work every year? We need to have more observations and we need to be able to repeat them to be able to have a dependable answer, as in yes, or maybe, or perhaps not.
Thank you, Martin.
Yep.
I've just realized we've only got 2 minutes left and we've got a huge load of questions.
Okay, so I'll stop here. I'll just leave this slide here. This is what we have learned so far. This could be a good slide to finish on.
Thank you so much. I'm sorry to cut you short there. Yeah, there was so much we could be talking about this, but just quickly, some of the questions to be able to answer. Somebody talking about it's a very good species for pollinators because of the nectar and pollen production, which is absolutely true. There's actually a symbiotic relationship between ants and Inga, which also increases biodiversity. But have you considered other tree species that play similar roles as Inga? Yes, we have. And also different Inga varieties. We're working primarily with Inga edulis. And that's because of the work of Mike Hans, who researched different Inga varieties. But there are still some that haven't been worked with, which we are trialing in Ecuador. We have to find out, do they resist being pollarded? The different altitudes that they grow at. So yeah, absolutely, diversity is key. And I think the more that we can incorporate even different Inga species within an alley, it's really important for us to move. And that is absolutely our next stage. So yeah, that's I totally agree with the worry about the kind of like the monocropping of using one species. But for right now, we just know it's the best use of the best tree for the job, and others have been trialed alongside it. So yeah, the bricks values, funnily enough, as we speak now, a bricks meter has been sent out to Jose, so we can start actually having a look into the bricks values. What fire management techniques do you need? Well, we don't have to worry so much in the Amazon about fire. So there's also the worry about it being an invasive species. Absolutely, that is always a concern too. So for us in Ecuador, it's native, that's where it comes from. But in Africa, where they've taken it already because of the production of coffee and cacao, which was how it got started in Cameroon and now Sierra Leone. So I think that maybe we can just quickly ask Stephen that about, I think we've got 1 minute. Stephen, what is the risk of Inga becoming an invasive species? Could you help us? What do you think about that? And Stephen, can you, are you there? I'm going to post into the chat right now for everybody, all of our contacts. So sadly, because we've had such a short period of time when we might not be able to get through all these questions, but if you look in the chat as well, there are all of our contacts for any kind of further follow-up. But I'm just trying to see, are we able to get Stephen back on? Yep, there's Stephen. So Stephen, what do you think about the concern of Inga becoming an invasive species in Africa?
Really, it is very great. Like I heard you mention about how to protect the Inga, more especially against fire. These are some of the strategy which I'm building up. Because like in most of the community where we are doing the Inga farming, we educate the peoples about the wildfire outbreak. Because like we have 2 seasons here in Sierra Leone. We have the dry season and the rainy season. And from now onwards, we are on the dry season. So most community, we have wildfire that come from a far distance, which we don't know. And it happens in our demonstration farm, which I taught the community that we have to build a fire belt. The fire belt have to be right across every Inga plantation so that we can protect the Inga against the fire outbreak and some other point. But Inga is really going to be something that will change our farming system and our life in Sierra Leone.
So what about the worry about it becoming invasive? It's not a native plant. What are your concerns there of it becoming invasive? I mean, we've always thought, well,
yeah.
If it was invasive, it's a very useful plant. But anyway, yeah, what do you?
It is. Yeah, it is a new species which we are doing our thorough studies on, and I'm quite sure based on the few experience we have got, it is going to serve for our purpose. Now, like in this season, where in a lot of community are now protecting the Inga, even commonly, despite the agricultural purposes. People are coming in to buy Inga just to establish a plot of land. So every year they perform picnics because of the better growth of Inga, create shade and other important ways, so that people will come around, say, share happiness and interact with each other. But I'm quite sure it is not going to be a new species that have any bad effect on the climate. We are looking at the good one for the moment, but in the subsequent time, if there's any bad things coming out from the Inga, we will know, but we have known the good one. So I'm quite sure Inga will serve our purpose.
Thank you, Stephen. I think exactly the same. I mean, from the work in Cameroon as well, although it's been a worry, because they are managed and it's not just kind of escaping. So, but it's always, you know, working with any invasive plant, you know, you've really got to take it into consideration. But sadly, we've run out of time. And so I really hope that we could further this conversation on at a later date. And it's such a shame that we didn't have more time for Q&A. But please contact us at Rainforest Saver and at Rory's Well. And so there's the direct contacts for myself and Stephen and Jose and Martin. So on behalf of all of us, thank you so much. And yeah, enjoy an amazing Oxford Real Farming Conference. So thank you all, and just, yeah, please spread the word about the importance of finding solutions to prevent deforestation in the tropics. And if agroforestry is a way, then, you know, the more people that can know about it, the better. So thank you very much.